Hello to all. Hello to all. Very good afternoon. So, ready for the workout session on bending and shear? Yes. Please share the link with your friends. Please share the link with your friends. Ask them to join the session. Ask them to join the session. Yes. Yes. Ask everyone to join the session first. Yes. Very good afternoon. Very good afternoon to all. So today I brought very good questions on the bending, right? You love those questions, and the concepts of bending will be clear. It's my guarantee. Okay. Yes. Please join the session fast. Join the session fast, beta. Yes. So as you know myself, Abhishek Sir, right? I've been teaching this field since 5 years. I have 5 years of teaching experience, right? And I've been qualified GATE and ESE 5 times, right? With the subjects I'm taking is 7, right? That is strength of material, structure analysis, geotech, open channel flow, surveying, environment, and CPM per. And if you want to take the subscription and use my code, use the code BHAR10 for promoting me. Okay. So start with the first question. Starting with the first question. Yes, look at the question, dear. Look at the question. Very good afternoon, Vishal, Aman, Akshay. Yes, very good afternoon. Very good afternoon. Yes, very good afternoon. So try to solve the first question. 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 Yes. Try to solve this first question. Just look at the question very properly. Yes. It is given that the bar of a rectangular section is supported and loaded as shown in the figure. Supports are where? At this position. These are the supports. The supports are 1.5 meter apart and the depth of the section is 125 mm. Okay. Then it says central deflection, that is delta, is given. This delta is given as 4.5 mm. Then find the maximum normal strain at the top and the bottom edge of the section. So this is given in the question. Yes, so this is given in the question. Yes. So tell me how you are going to solve this. Tell me how you are going to solve this. Tell me how you are going to solve this. Yes. What do you know? A bar is of rectangular cross section, is supported and loaded. Right. See, we know that when you apply a load, it will bend in the form of an arc, circular arc. Right. And if this length is L by 2, L by 2, what we know? We know that, solve this type of question also. Bend, if it bend in the form of arc by the property of circle, this is L by 2, L by 2, this is delta. Then the other part is 2r minus delta. So from the circle property, we can write L by 2 into L by 2 is equal to 2r minus delta into delta. 2r minus delta into delta. Right? So this become L square by 4 is equal to 2r delta minus delta square. So delta is very small, so delta square will tend to 0. Yes, delta square will tend to 0. Thereafter your delta will be what? L square by 8r. So this we have already seen. Okay, so obviously this is going to be used. Okay, so in this question you have been asked to find the strain, maximum normal strain of the top and bottom edge. So obviously if it is bending, then and it's a rectangular cross section, so both the strain at the top and bottom edge will be same. Yes, so strain at the top and bottom edge will be same, right? So we can use the bending equation, that is m by I is equal to sigma by y is equal to E by R. Okay, so I will be using this part. That is nothing but epsilon we write as sigma by E. So if we write sigma by E, we'll write y by R. Since we are talking at the surface, that is the maximum strain, so this will be what? Y max. So we need to write y max by R. So what is y max? If the depth of the section is 125, y max will be what? 125 divided by 2, because it's a rectangular cross section, the centroid lies in the mid one. Yes. Thereafter, after you get 125 by 2, what is the R? R you can find by using the formula L square by 8 delta. Come on, get me the value, beta. Come on, get me the value. Look at the units properly. Get me the value. See the units properly and find the value of delta. That is strain. Yes, I will be taking the geotech. I will be taking geotech, beta, from 17th, I think, from 17th or 16th. I will be confirming you that, don't worry. Yes, and that is in the drone batch. That is a Hindi batch. Yes. Come on, reply this answer. Reply to this. What is the value? Please like the video and share with your friends. Yes, give me the value of this. Make sure this is in mm. So bottom also it should be in mm. Yes. This is 125 by 2. Length you need to put in mm. So that is what? 1.5 meter apart. That is 1500 mm whole square. 1500 mm whole square divided by 8 into delta. Delta is what? Delta is 4.5. Yes, get me the value. Get me the value of maximum strain, beta. Get the value of the maximum strain. Yes. Get the value of maximum strain. Yes. Get the value of maximum strain. Yes. Who is going to give me the answer? Yes. What is the answer, beta? What is the answer? Yes, what is the answer? It should be, yes, very good. 0.0001. 0.001. That is option number B. So B is the correct answer. Very good, Adesh. Okay. Next question. Try to solve this question, beta. What is said in the question? A wooden railroad sleeper, 2.5 meter long. This is a wooden railroad sleeper. It's a 2.5 meter long. It is resting on the blast, carrying 2 point loads. It is carrying 2 point load. You can see 175 kilonewton, each as shown in the figure. The sleeper section, that is a cross section, rectangular cross section, is given by 300 by 250 mm. Find the maximum bending stress in the sleeper, assuming the reaction of the blast is uniformly distributed over the entire length. Okay, so whatever this load is acting, this load will be resisted as a uniformly distributed load, as a reaction. Okay, so what you need to find? You need to find maximum bending stress. That is nothing but sigma max. And again, this sigma max will be coming obviously at the surface. The sigma max will be coming at the surface. If this is the neutral axis, yes, you can clearly see that it will come at the surface. That is y max you need to find. You need to look. Okay, so you are asking the sigma max. Sigma max will be what? Nothing but m max by Z. M maths by Z. You need to find this M maths by Z. So for a rectangular cross section, what is Z value? So for a rectangular cross section, what is Z value? Yes, what we write Z value? Nothing but BD square by 6. Nothing but BD square by 6. That is the value of Z. That is the value of Z. Yes. So BD square by 6. So what is the BD square by 6? Width is 300. Width is 300. Depth is 250. So 250 whole square divided by 6. This is the value of Z, which you get in mm cube. Which you get in mm cube. Which you get in mm cube. Okay. So this is the value of Z. Now you need to find M maths for determining the sigma maths. You need to find the M maths for determining the sigma maths. Yes, who can tell me how to find the M maths? Yes, who can tell me how to find the M maths? Yes. Who can tell me how to find the M maths, dear? Yes, who can tell me how to find the M maths? Maximum bending moment. M maths, maximum bending moment. What should be the maximum bending moment? What should be the maximum bending moment? Yes. What should be the maximum bending moment? Tell me first, what should be the maximum bending moment? How you are going to find the maximum bending moment? Yes. Yes. See dear, first of all you need to find this UDL. So if you find this UDL, that is nothing but the total load will be resisted by this UDL. So W, if I talk, the total load is what? Nothing but 350. That should be distributed over a length of 2.5 meter. So from here you will get the value of W in kilonewton per meter. Okay. Now the maximum bending moment occur at 3 points. That is in terms of magnitude, either at the center or at the support. It will occur either at the center or at the support. Okay. So what is the maximum bending? What is the bending moment? If I say, give the name A, B, C, D and E. So what is the bending moment at B? What is the bending moment at B? What is the bending moment at B? Yes, what you can write? What is the value of W first? Tell me the value of W. Tell me the value of W first. Yes, what is the value of W, beta? 0 cancelled. 25. 1s are 25. 10, 4, 140. Is it? Is it 140 kilonewton per meter? Is it 140 kilonewton per meter? Yes or no? Is it 140 kilonewton per meter? Yes? Okay. So, if I talk about the bending moment at B, what you are going to write? 140 into 0.5. That is what you are going to write. 140 into 0.5. This is the total load. And the lever arm is 0.5 by 2. Lever arm is 0.5 by 2. So this value, yes. So this value will be what? 70 by 2 into 0.5. So that is how much? 35 by 2. 35 by 2, that is nothing but 17.5 kilonewton meter. And same bending moment you are going to observe at D also because of symmetry. Okay, because of symmetry. Now I want to find at the center, because at the center it can be maximum part. So at E, what is the bending moment at E? What is the bending moment at E? What is the bending moment at E? Yes. What will be the bending moment at E, dear? What will be the bending moment at E? So if I take the length of the UDL in this part, if I take the length of UDL in this part, it will be what? 2.5 by 2, that is nothing but 1.25. Okay. And the other part will be 0.75. So if you take the moment, it will be what? 140 into 1.25 is the total load. and the lever arm is 1.25 by 2. The lever arm is 1.25 by 2. Okay, the lever arm is 1.25 by 2. And from this, we are going to subtract 175 into 0.75. 175 into 0.75 minus we have used because it is in the opposite direction. Okay. So, from here, get me the value of bending moment at E. Yes, get me the value of bending moment at E. Yes, get me the value of bending moment at E. Yes, everyone, give me the value of bending moment at E, beta. Give me the value of bending moment at E. Yes, give me the value of bending moment at E. Those who have joined just now, please like the video. Yes, give me the value of bending moment at E. Bending moment at E. What should be the value of bending moment at E? The answer will be in kilonewton meter. The answer will be in kilonewton meter. Yes, give me the value of bending moment at E, beta. Yes, what is the value? What is the value, beta? What is the bending moment at E? What is the bending moment at E, beta? Yes, minus 21.875 kilonewton meter. That is the bending moment at E. That maximum bending moment. What is the maximum bending moment? Yes, what is the maximum bending moment? What is the maximum bending moment? Nothing but, in terms of magnitude I need to talk. So that is nothing but 21.875 kilonewton meter. Everyone like the video, those who have joined just now. Yes. So the maximum bending moment you have find as 21.875 kilonewton meter. Okay. You have find the maximum bending moment as 21.875 kilonewton meter. Now, you know M maths, you know Z. You know M maths, you know Z. You need to just find the sigma maths now. You need to just find the sigma maths now. So what is sigma maths? Nothing but M maths divided by Z. So M maths is what? 21.875 kilonewton meter, converting the Newton mm, so multiply with 10 power 6 divided by, what is the value of Z? You have already done 300 into 250 whole square by 6. 300 into 250 whole square by 6. Yes, give me the value, beta. Give me the value of sigma maths. 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 Yes, what is the value of sigma maths? What is the answer you are getting? Yes, 7 Newton per mm square or 7 megapascal or 7 megapascal. So the correct answer is 7. That is C. Correct answer is C. Very good. Adesh, Sashank, very good. Very good. So the correct answer is 7 megapascal. Very good. Yes. How was the question, beta? How was the question? How was the question? Tell me, how was the question, beta? You are able to link, right? You are able to link how the bending is linked with the moment and everything. Yes. And here is the only the part where you are facing the problem. So I've taken this type of questions only for the session. Yes. Okay. So next question. Next question. Yes, see the question number 3. Try to solve this question. It's a very easy question. It's a very easy question. Provided you understand, then only it is a very easy question. Provided you understand, then only it is a very easy question. Yes. Try to answer this. Try to answer this. Try to answer the third question. Tell me what you are going to do. It is a high strength steel wire of diameter D is bent around a circular drum of radius R0. Find the bending moment and the maximum bending stress in the wire. Taking the diameter of the wire that's a drum. The wire diameter is 4 mm. R naught, that is the radius of R, is 0.5 mm, and E is equal to 2 into 10 power 5. So this is given to you in the question. Okay, so just a hint, this wire when bent in the form of an arc, this wire bent in the form of an arc around a circular drum, so obviously this particular wire will move along this drum, right? The radius of the wire will be along the drum. Okay, so the center of this wire will be what? What will be the center of the wire? Nothing but R naught plus D by 2. The center of the wire that is bent around the drum will be what? From the center of the drum to the neutral axis of the wire, that is nothing but R naught plus D by 2. Okay, so if it is R naught plus D by 2, the radius is R naught plus D by 2. Okay, the radius of the part is R naught plus D by 2. So what we are going to write? We got the radius part, radius of arc, R, that is what? R naught plus D by 2. This is the radius over which the bend is going to occur. So R naught is given, that is 0.5 meter. D is 4 mm, so that is 0.004 by 2. So the value you are going to get is 0.502 meter. 0.502 meter. This is your R value. Okay, so you got R, you have E, you have R. You have been asked to find the maximum bending moment. So what you are going to write? You have the formula M by I is equal to sigma by Y is equal to E by R. So if it is asked the maximum bending moment, you can use the formula M barabar E by R into Y. Yes or no? You can use this formula M barabar E by R into Y. Yes, and if someone asks you what is sigma, right, that is obviously sigma maths, right? Obviously this is Y maths it is asking. Sigma maths, if it is the same, what you are going to write? E by R into Y maths. So one minute. This is your what? This value will be your E by R into I, neutral axis, and here it is Y maths. Okay, so yes, come on, try to get the answer. It is a circular cross section. Yes, it is a circular cross section. The diameter of the circular cross section is given to you. Try to find the value of M and sigma maths. Try to find the value of M and sigma maths. Yes, everyone. Try to find the value of M and sigma maths. Yes. Try to get the value of M and sigma maths. Try to get the value of M and sigma maths, beta. Yes. Try to get the value of M and sigma maths. Actually, these were the question I did in the live test, because few students were not able to answer much of the question. That's why I thought to repeat this question here so that you all can understand each and every part. Okay. Yes. Get me the value of M and sigma maths from these relations. You know the value of R, you know the value of diameter, you know the value of E. Try to get the answer. Okay, so I neutral axis, this is a circular cross section. So at the cross section, if you look, it will be circular. So obviously the I will be given as pi d to the power 4 by 64. Okay, so m, if I find, that is nothing but E by R into I. So what you are going to get? What you are going to get E is 2 into 10 to the power 5. E is 10 to the power 5. R you are getting as 0.502, right? 0.502 meter. And I neutral axis is pi d to the power 4. D is nothing but 4 mm. Pi into 4 to the power 4 divided by 64. So what value you are getting? Yes, what value you are getting? Yes, I think 64 is cancelling out. Yes, 2 4s are 8, around 16 into 5, 3.14. 5003, yes, very good. 5003.98, very good. 5003.98 unit. What is the unit? It is Newton mm. No, it will be Newton meter, right? Okay, here you have divided by 10 power 3. Then you are giving me the answer. Okay, then it is Newton meter. Okay, Newton meter. Okay, next. Yes, next. Sigma. What you are going to get? Sigma E by R into Y maths. Sigma you are going to get E by R into Y maths. So E is what? 2 into 10 power 5. R you have seen 0.502. Okay, and this multiply with D by 2, that is what? 4 by 2. So the value you are getting as 796.81 Newton per mm square. Is it? Are you getting this value? Yes. Just check this one. If any error is there. 200 by 0.5. Yes, it will be right. Okay. So 796.8. So correct answer will be what? Correct answer is D. D is your correct answer. Okay. So that's what I'm saying. We are saying again and again that why we are preferring the plus over this. Because if first of all you can understand we are doing so good questions, right? But still you cannot see that competitive environment, right? Which you can't see in the plus. You can see the way the students are commenting. So the first of all that we always say that one thing that you lag over here is competitive environment, which is available when you look at the plus. And for any competitive exam clearation, right? For any competitive exam, if you want to prepare, you need to have a proper dedicated path, right? The classes will be in English, Hindi. The doubt clearance after every third day, the fourth day is the doubt clearance. Weekly test, 7th day of the class, there is a test is there. RIB is there, crash course, live classes. So everything is there. So which is of very immense importance. So those who are planning for any subscription, they can contact me with this number. That is 8210570910. You can contact me on this number, right, for any clarification. Okay, coming to the next question. Solve the next question, beta. Solve the next question. What is said? An I section beam is simply supported over a span of 10 meter. If the maximum permissible bending is 80 Newton per mm square, then what concentrated can be applied at a distance of 3.5 meter from one support. Okay, do you like to try this? Yes, do you like to try this? Say it here. Would you like to try this question? Yes. Would you like to try this question? Yes. I section beam is simply supported over a span of 10 meter. There is a span of 10 meter. There is a span of 10 meter. If you look at the longitudinal view, you can see it's a simply supported beam. Okay. This simply supported beam has a span of 10 meter. Okay. And it is said that what concentrated load you need to apply at a distance of 3.5 meter. So suppose this is P. So what concentrated load you need to apply at this? This is 3.5. So other is what? 6.5 meter. Okay. So it is asking that what is the concentrated load? What is the concentrated load? So what do you need to answer? You need to find P value. You have been given sigma maths. You have been given I section. So we know that the M is equal to what? Sigma maths into I by Y maths. This we know for moment carrying capacity. Okay. So I we can find from this part. We know how to find the moment of inertia of the rectangular cross section. Okay. Y maths we can find this since it is symmetric, the neutral axis will lie at the center. And sigma maths is given in the question. What is the maximum bending moment? What is the maximum bending moment? What is M maths? What is M maths? Nothing but P into 3.5 into 6.5 divided by 10. Divided by 10. PAB by L. That's the maximum bending moment. Okay. So you got the value of maximum in terms of P. You have been given the sigma maths value. I value you can find for the I section, and Y maths is known. Come on, try to get the answer. Try to get the answer, beta. Yes. Sigma maths is 80. This is your sigma maths. I you need to find. Already I have taught you how to find I for a I section. Moment of inertia for an I section I have already taught you. Yes, try to get the answer. Try to get the answer for I. Very easy. Very easy. I neutral axis. Very easy to find I neutral axis. Very easy to find I neutral axis. If you remember, taking the entire as a rectangular, then subtracting the half, the extra portion that we have taken. Yes. You don't remember, remind it now. I'm doing it in the next page. I neutral axis. This is equal to what? 100 into 225. 100 into 225 whole cube by 12. So consider the entire as a rectangular area. We have taken that. Subtracting the extra portion. So if I take only this one, so what we can write? 100 minus 7.5 by 2. This is 202. So minus 100 minus 7.5 by 2. Okay. This multiplied with 202 whole cube by 202 whole cube. BD cube by 12 you need to write. By 12. And this again multiply by 2 because two sides are there. So 2 and 2 cancelled out. Give me the value of I neutral axis. Give me the value of I neutral axis. Yes. Give me the value of I neutral axis. Give me the value of I neutral axis, beta. Yes. Give me the value of I neutral axis. Give me the value of I neutral axis fast. Yes. What is the value? What is the value of I neutral axis? Solve it fast. Get me the value of I neutral axis. Fast. This type of questions only they used to ask in the exam. Okay. So if you are prepared for such type of question, there will not a single question in the strength of material that you are going to miss in the exam. Okay. Try to get me the answer. Try to get me the answer. Is it 3138.6 into 10 to the power 4 mm ka power 4? Yes. Is the value I neutral axis 3.3138.6 into 10 power 4 mm ka power 4? Yes, very good, Aman. Right. So you got I neutral axis. Okay. Y maths is nothing but 225 by 2. Y maths is nothing but 225 by 2. That is nothing but 112.5 mm. Okay. So you need to find this value, that is P. So what we can write? P into 3.2. This is in kilonewton meter. That is 10, right? PAB by N. So this is in kilonewton meter. We need to convert in Newton mm. So multiply with 10 power 6. Right? Then the stress is 80 Newton per mm square. That is 80. This multiply with I by Y. So I is what? 31.38 into 10 power 6. And this divided by Y maths, that is 112.5. Yes, give me the value of P. The P you are going to get in kilonewton. The P you are going to get in kilonewton. The P you are going to get in kilonewton. The P value you are going to get in kilonewton. Yes, give me the value of P. This 10 power 6, 10 power 6 cancelled out. Okay, got the point. This 10 power 6, 10 power 6 cancelled out. Yes, give me the value. What is the value of P? What is the value of P that should be applied? 9800, 9810, 9820, 9830. What should be the value? What should be the value? Yes. What should be the value? What should be the value of P? Yes, tell me dear, what should be the value of P? Yes. What is the value of P you are getting? What is the value of P you are getting? The answer that you are going to get from here is in kilonewton, because if you haven't kept in kilonewton, you cannot multiply with 10 power 6. Yes. So give me the answer. It should be near about 9.81 kilonewton. It should be near about 9.81 kilonewton. So out of the 4 options, the answer will be B. B is your correct answer. Is it clear to all? Is it clear to all? Yes, is it clear to all? Tell me dear, is it clear to all? Okay. So that's it from today's class. I'm not going to tell anything else. We will be doing the workout session on deflection in the special class. I will inform you the schedule. Okay. And your soil is going to start in the your Drona batch from 6 to 7:30. The time will be 6 to 7:30. Right. The time will be 6 to 7:30. Okay. It will start in the Drona batch from Thursday. Right, it start in the Drona batch from Thursday. Okay, so don't worry about soil and everything. I will be taking care of that. Okay then.